Hello, welcome to this video. Today we're going to do this problem that I actually came up with. So we need to show that for every function f from r cross r to r bigger than or equal to 0, that satisfies f of x y is equal to f of y x. So like these two are interchangeable. For all x, y, z such that x is smaller than or equal to y, which is smaller than or equal to z, we have f of x y, f of x comma y plus f of x comma plus f of y comma z equals f of x comma z, and if f is bounded, so there's like some positive value m, such that for every two values x and y, f of x comma y is smaller than or equal than m. Show that there exists a function g from r to r bigger than or equal to 0, such that f of x comma y is the absolute value of g of x minus g of y for all x and y. So let's begin. So first thing I'll observe is if we move this f of y comma z to the other side, we'll have f of x comma y equals f of x comma z minus f of y comma z, which if we define that function as g of, so like g of x is f of x comma z, then it seems like we're done, right? So I have right, so it seems like I have g of x minus g of y is f of x comma y and I'm done. But in reality, that would only hold true for x smaller than or equal to y smaller than or equal to z. So the actual thing we'll do is, first of all, not talk about any z, but specifically about 0. So, it also works for other values. 0 is just the sort of the most obvious one to pick. So, right, so this is going to be z. So, like I said, it seemed like choosing g of x to be f of x comma z, which we're saying specifically the value 0, it seems like that will work, but it doesn't, because if we had the case where x is bigger than y, or z is the smallest out of all of them, or like 0 is the smallest of all of them, things like that, it all falls apart. So instead what I'm going to do is take, so this sort of function comes off after playing with this for different cases of x, y, z, but you eventually can come up with f of x comma 0 if x is bigger than or equal to 0, and if x is smaller than 0, we're going to do the negative of x comma 0. So first of all, g of x is not from r to r bigger than or equal to 0, since this is negative for x that are negative. But we'll fix that. For now, let's see that this function works. So we want x and y, and we want to show that f of x, y is the absolute value of g of x minus g of y. So we're going to look at 3 different cases. X bigger than or equal to y bigger than or equal to 0, x bigger than or equal to 0 bigger than or equal to y, 0 bigger than or equal to x bigger than or equal to y. Now it seems like there should be more cases, right? What if y is bigger than or equal to x bigger than or equal to 0? But we don't need to check that case, because if we just swap x and y around here, because in the function f, x and y are interchangeable, then switching them here will not affect our result. So we'll just show for these 3 cases. So for the first case, we have 0 smaller than or equal to y smaller than or equal to x. So f of 0 comma y plus f of y comma x equals f of 0 comma x, right? So this is f of x, y, since x and y are interchangeable. this, and because they're interchangeable, again, this would be g of x, and this would be g of y, right? Because both of them are bigger than or equal than 0, and then I can choose them to be that way. Okay, so now I get that f of x of y is equal to g of x minus g of y, right? And because f is to r bigger than or equal than 0, then I can just put an absolute value over it and still be fine. Right? So that's the first case. Second case, we have y smaller than or equal to 0, smaller than or equal than x. So we will get that f of y comma 0 plus f of 0 comma x is equal to f of y comma x. So now this is g of x, but this is negative g of y, right? Because y is smaller than or equal than 0, and so that's the case. And I should mention, so it's this case. But I should mention that it seems like, well, what if y equals 0? It would be positive f of 0 comma 0, not negative of it. Well, I'll let the actual thing. The thing is, f of anything, comma itself. So f of say 2 comma 2 is 0 here. Why? Well, if I here have the condition that x is smaller to y, smaller or equal to z. If I take z is equal to y, I'll have f of x comma y plus f of y comma y plus f of x comma y, right? And I can obviously just choose x that is smaller than or equal to y, right? I can choose actually y itself. It'll actually work if I choose x, y, and z are all equal to the same thing. But even if I don't do that, and I just choose y and z to be the same, then this and this will cancel out, and I'll have that f of y comma y is 0. Right? So if y was 0, it would be positive f of 0 comma 0 or negative f of 0 comma 0. Both of them would have the value of 0, so it doesn't matter. Right? So this is g of x, this is negative g of y. And we got that f of x comma y, right? They're interchangeable. Is equal to g of x minus g of y, right? G of x minus g of y. And again, we can just put the absolute value over it, since f is big, since f is to r bigger than or equal than 0. Right? And the final case we're gonna do is this one. We have y smaller than to x smaller than or equal to 0, meaning that f of y comma x plus f of f of y comma x plus f of x comma 0 equals f of y comma 0. Now, this is negative g of y, this is negative g of x. If I move to the other side, I'll have g of x minus g of y. And this is f of x comma y. So I get that f of x comma y is equal to the absolute value of g of x minus g of y. Right, and again I can just put the absolute value over it, since f is to r bigger than or equal to 0. Now, I also should say, I should still look at the case if x was smaller than y, just to make sure that it works. So if x was smaller than y, then they would flip positions here. So I'd have f of y comma x is equal to the absolute value of g of y minus g of x. But in the absolute value, I can just flip them around, since that's just the same as multiplying by negative 1, which in the absolute value doesn't matter. And I can change x and y inside the f, since they're interchangeable by this thing. So again, f of x comma y is the absolute value of g of x minus g of y, which is exactly what I want. So even for the case when x is smaller than y, it works. But now, there's one last thing that's we didn't quite finish yet. There's one last thing that's stopping us here. We want g to be from r to r bigger than or equal than 0. But here, like I said earlier, this is clearly negative. So how do we solve this? Well, we still haven't used that f is bounded. Let's say that f of x comma y will denote its upper bound by m. So f of x comma y is smaller or equal to m for all values x and y. I can say, let's look at g tilde x, which is just g of x plus m. Now I have here, at the top I would have m plus f of x comma 0, which is clearly non-negative. And in the bottom I'll have m minus f of x comma 0, which, because of this thing, is also non-negative. So g tilde of x is now not non-negative. It goes from r to r bigger than or equal to 0. And clearly, since f of x comma y is the absolute value of g of x minus g of y, I can say that the absolute value of g tilde x minus g tilde y is the absolute value of g of x plus m minus g of y minus m, which is the absolute value of g of x minus y, which is f of x comma y. And so we found it. G tilde is a function from r to r bigger than or equal to 0 that satisfies f of x comma y is the absolute value of g tilde x minus g tilde y. And that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.